scale drawings are very handy things to have because they take something very, very big and shrink it to fit on a piece of paper, or something that's very, very small and enlarge it so that we can see details. So, for example, when you think about a map, if I want to know the distance between New York and Florida on a map, well, I can't fit the United States on a piece of paper. So we have to shrink it. But we have to shrink it so that the shrunken version looks exactly like the United States in real life. And to do that, we use proportions. So I'm going to take a simple example here. I have a rectangle, and this rectangle, let's say, represents a building. And my scale factor is that 1 centimeter or 1 unit on this paper represents 10 feet in real life. Okay, sometimes we call this the model, and we call this the actual, and that gives us a little easy way to remember it when we start using when we start doing it without the actual picture. So if I look at this building, okay, in my model or drawing, you can use drawing or model, doesn't matter. Okay, I have 3 centimeters by 5 centimeters. Okay, and we can label it. Okay, now I want to know how big is this building in real life. So what I'm going to do is I'm going to take my initial ratio here, and I'm going to write it as a fraction, okay? And it's going to be 1 centimeter represents 10 feet. And I'm going to create a proportion. So if 1 centimeter, so every centimeter in this drawing represents 10 feet in real life. So if the height is 3 centimeters, then what do I have to do? I have to multiply by 3, which means I have to multiply this by 3. And that means that in real life, this building would be 30 feet on this side. And then for the other side, I would have 5 centimeters represents, whoops, I have to do 1 centimeter. We always have to go back to the original ratio. 1 centimeter is 10 feet, so that 5 centimeters would be 50 feet. And so in real life, we know that this building would be 50 feet by 30 feet. Okay, and that's just the basis of any problem that we're going to do. And sometimes, depending on whether you refer to it as a model or a drawing, we kind of remind ourselves by saying model over actual equals model over actuals. We say mama, right? M-A, mama. Or we can use, if you prefer dada, you can use the drawing over the actual equals the drawing over the actual. So let's take an example. Let's say, let's say a builder is building a house from a blueprint. And the blueprint has a scale of 1 foot on the drawing, because blueprints are big, is 40 feet in real life. Okay? And we have one of the walls is 3 feet long. Okay? And they want to know what is the length of the wall in real life, or the actual length. Okay, so we're just going to set up, in this case, since it's a blueprint, we'll call it a drawing, so we'll say D over A equals D over A. All right, and so in the drawing, okay, so this is the drawing, and this is the actual. Okay, so in the drawing, 1 foot represents 40 feet in real life. Okay, and in our particular blueprint, the wall is 3 feet long, and so they want to know this, right? Okay, so what are we going to do? 1 times 3. So we have to multiply 40 times 3, and that would be 120 feet. And so you can see that in real life, the wall would be 120 feet long.